Welcome back, generals, to another Let's Fix Generals 0 Hour to make the best game ever. Good, so we have, what do we have? We have, last session we added a bunch of new functions that we wanted to implement, yeah. I think we should start with this one. Build class or namespace from variable. Build class or namespace. Yeah, which basically should be similar to this one, right? Yeah, I think it will be similar to this one. So we will have variable index here, and then we will have variable, and then if not variable decal context name empty, then we check if it is a known namespace or is known class. Yeah. And then we can check, is it expected class? Then we assign it as a class, create a class. Otherwise, variable namespace is variable indices, function indices. Yeah. I wonder if we base name. I wonder if we should adjust the names here to say entire name. What is the difference between mname and function name? Do we use it for anything? Get function name. Can we put a breakpoint here? I already forgot what that means. Function name is the exact without the base name. maybe we say it's the context name and base name without parameter, without argument list. Let's call it parameter lists. Parameter, because this one is called parameters here. How about we call this base name let's say name without parameters. Yeah, let's call it name without parameters. Then we rename this one to base name. This one to decl context name. This one to parameters. And this one return type. And this one parameter types. Parameter types. There we go. And then we parameter types. Then we go to here and we do the same here. Base name, and decl context name. There we go. Good. Good. That's nice. The context name of this variable. Context name, how do we say here? Function. The context name. Context name. Okay, I think we can also remove this address field. Unclear what this ID refers to exactly, but we can use it to generate an ID with the name. But we use it to generate an ID. Okay, that's good. We have a bunch of red now here. Yeah. The rename function doesn't really work well. It fails to yeah, find some things. Name without parameters. Parameters. Return type. Parameter types. Parameters. Okay. Take a context name. Ta-da. Oh boy. Strangely here it found it. Weird. Okay, so that seems to be good. It compiles, yeah. Okay, so this, let's put a breakpoint in here. So I assume that it only hits it a few times here to find a new class. Yeah, yeah. One namespace. Okay, what do we have here? We don't care. Yeah, let it run. Okay, so build class or namespaces from variable. Has no context name. Okay, let's jump in here. So here we have a context name. Its namespace is class false. Oh, because it's a function. Hold on. Variable. The context is a function. So in that case, if hold on, has context. If not, is in function. Yeah. So we need to say if not empty and variable dot is not in function and yeah, basically all of these need to be false. So variable is not is in namespace, yeah, and not variable is in class. Yeah. Yeah. Okay, let's see how often that hits. Okay, there we go. C stream sound. Okay, I'm surprised that this is not build class or namespace from variable. C stream sound. Let me see. C stream sound. Find all. So we're looking at beginning beginning here, I think. Maybe late. But there are functions. Huh? Huh? Okay, that is unexpected, no? Something is unexpected. Let me see. Ah. 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 No. Basically, we haven't built relationships yet, right? That's why. Yeah, we haven't built the class and the other relationships yet. That's why it enters here. That's why this is never false. This is never true in class, in namespace. Yeah. So we can probably, we could omit these, but we can also just keep them. I mean, they're useless checks because of the order, but in itself, it's not wrong to check it here. It's not wrong. I would say we keep it. Yeah, I think it's fine. Okay, then here we would check is namespace false, is class true. Okay, so it's already known, and so nothing is done here. That's fair. See stream sound again. Variable. Okay, then let's put a breakpoint in here. So that's next step. Okay. Cfence. That looks good. Yeah, cfence. And that we expect a class, I think. Yeah. Cfence. Well, I think this expected class will probably fail. As function argument ends with struct. Yeah. How about we say here, or starts with the common, well, if starts with name, starts with name C. Well, let's say if name 0 is C and std is upper name 1. Return true. Class is indicated in name 2. And here we can also say is C or name 0 is S. But yeah. I'm not a fan of this because there could be something that starts with C and then another uppercase. Here it's way more explicit, right? Class instruct, like it's right in the name, so this one is pretty clear, but this one it's a bit more fishy. Yeah. It's a bit more fishy. Yeah. It's a bit so let's say if this or that, and then for let's say while for const char C equals name 1 and then C is not null plus plus C, and then if std is lower, so if there's at least one lowercase character in there. By the way, this is wrong because should be name.data plus 1. And then here do is lower C. Yeah. Then we return to class is indicated in name. Okay. Maybe that's okay. So if the class starts with Hold on. S C C. We should probably say, hold on. if std upper name one. Ah, no, we already have it here. Never mind. Then we need to start it too. Yeah. Yeah. How about we put another condition here? We make a nice ladder of conditions. So if it's C or S, then we do that. Then we check is upper, because it was a bit sneaky up here, so I would like to have it a bit more visible. So if it is upper, so the first one, let's add a comment here. C my class or S my struct. C my class. C my class. C my S my struct. Considered classes. Okay. Okay, let's see. That's good. Oof. What happened here? Oh. Oh. Right. Okay. So here we have cfence, and now basically it should be considered a class because this will be is lower, and there we go. Straight pass. It's expected class, cfence. And just like that, we have another class. Let's see if we get another one. Music track. Yeah, what this could be, I think this will be a namespace. Yeah, it will be classified as a namespace. Okay, that's fair. Map metadata reader. This is probably a class, but this will be classified now as a namespace, which is fair. Oh, anonymous namespace. Oh, holy shit. Huh. Huh. No, that is interesting. Huh. That's very interesting. Wow. Okay. Let me copy the value here and search for it. There it is. Just once. Huh? Oh, this namespace. Yeah. Starting money field pass table. unnamed. But where do we get that from, though? Because we didn't pass this thing yet here. We didn't pass this yet. And I think I don't know what that is. I don't know where this is coming from. Variables. Anonymous namespace. Starting money field pass table. I'm really confused where this is coming from because we're not reading this thing yet. Or are we? Huh. 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 Yeah, I don't know what that means. I don't know what that means. I would like to find out where this is coming from. Tackle context name. Tackle context name. Parse has context name. If tackle context name equals that thing, then please put a breakpoint. Test. I need to know. That's interesting, yeah. So the symbol is, oh, ZN global. Okay. Global and parts. But where does this parse multiplayer settings definition thing go to? Base name, name. What about this parse multiplayer settings definition? Where's this ending up? I don't understand. I'm confused. So we have this here. Why is this being swallowed? Huh? Huh? Fair definition. Starting money. So I suspect that this parse table is used inside this parse multiplayer settings definition, right? Probably will be referenced in there. But then that's weird. That's weird. But here's a confirmation that it's supposed to be like that. Yeah. Okay, well, we just go with it for now. Then how about we do the following? The namespace thingy. Namespace. Let's copy this. Create namespace. Create namespace. Find or create namespace. There we go. Name. Namespace name. Context now. We should probably it's maybe class. So let's add another bool here. Bool is anonymous. False. Anonymous namespace. Let's copy this one here. Class name. Yeah. Okay. It's a number. Okay. So what we say is namespace. Index. Yeah, let's say here namespace type dot is anonymous equals this name equals that unholy string, this one equals that. Actually, namespace name. This one actually needs to be done later here. We need this one. On that note, why do we make it so complicated here? Why don't we push back it later? Why don't we push back at the end? Namespace type, namespace name, so index is that. Name. Namespace name. Let's take this one, name. Let's move here, namespace name. There we go. I think that's better. And then here we say namespace type, type. Namespace name is anonymous, namespace name equals that, yeah. I think this is correct, yeah. Can probably also make this one const. Now what we changed is the order that these things are created, because now this one is created before this one. But is that a problem? Don't think so. Probably not. Probably not. Okay, so here we also need to say namespace index. Let's do a namespace equals that. Namespace type. Namespace type, class indices, and then we also do is maybe class true, right? Because we're not sure. Yeah. Okay, then we copy this, and then we also put this here. Build class. Hold on. Find or create class by name. Find or create class by name. Don't we have like multiple copies of this here by now? Build class or namespace from function. Hold on. It looks very similar, doesn't it? Let me see. Let's make a copy of this one. If it is very similar, then maybe it would be good to have to combine it into a function. So we got this. Let's put a marker here. We have this. Put another marker. And this. So these things look very similar, don't they? Like a context name. Yeah. So we need to also do this over here. Here. Class index find. Oh, but this is different here. Parent. Index. M classes. Classes. Here we have this optimization. Yeah, I mean they're very similar, but there's some difference here with this one. So here, no, with so here we put it into class. Here we put it into function, and here we put it into variable. Same here, here, and here. Yeah, so that's the main difference. Otherwise, it's very identical what we're doing. Well, there's also a difference here. Yeah, I don't think we can easily consolidate this into one function, and we probably should. Okay, then what we should do is we take this stuff here and we put it here. And then we have variable indices, variable index. Yeah, namespace, variable. Okay, this seems to be fine. And the other one here, that's function indices, namespace, and function indices, function index. There we go. Okay, this may be class true. Yeah, okay. And maybe we should also, here we say index. Maybe we should class type. Maybe we should have class index. Class index. Oh, by the way, I think I realized that this is wrong, what we just did there in the namespace. Yeah, I think so. Find or create namespace. I think what we just did there, since it's nested, yeah, this what we did here is wrong. The pushback needs to happen here, because otherwise multiple things, if it's nested, will use the same index. Right? That's not right. So here we should say index namespace index and namespace scmove, and then we do name. What we can do is we put it here into a scope, and then we put a namespace index here, namespace type reference, or just a name dot back. There we go. And this is -1. There we go. Yeah. What we can also do, why we make it so complicated? Just push back, mplace, just mplace back. There we go. Then assign this, and then do this. There, much simpler. Yeah, good. Names, yeah, that's correct now. Yeah, good. So namespace is back. Size -1. Yeah, I think this is correct now. Okay. Then I think what we can also do is make these guys here const. And then mClass is class index. Okay, and then we go to the next one. Const next. Okay, I think that looks parent class and next class. Parent class and next. Yeah, class and next. Okay. And then what we do is here in the find or create class, we do the same thing here. Here at the top, we do mplace back, and then we do class type equals m classes dot back, and then we assign class index here. Boom. Great. Class type, and then instead of this, we can simplify this to that. Class type. There we go. And yeah. And then we can maybe do the same thing in some other classes where this is here. Mplace back variable equals variables dot back. Index. Okay. And then we do the same here. Enums mplace back. There we go. Enum type and enums dot back. There we go. Name blah blah blah. Okay. And here as well. Mplace back. Header file. Header files dot back. Okay, and short variable name. Okay, that's it, I think. Mplace back, header file. There we go. Actually, oh no. I'm stupid. I'm stupid. Yeah. This is not correct, Cecil. Okay, let's revert this stuff. The reason we did this with the indexing is because we have nested creation, and there can be an event where it reallocates the vector, and then we need to index, and we can't keep a reference. That's why we do this. Now here we don't create nested variable. Build class on namespace. Build class on namespace from function. Function. Let's simplify this to just, we do this. Same here. And here. Okay, we need to be very careful here. Maybe we should add some comment. Find out create namespace. Yeah, so this one is also a problem. So we need to, yeah. Okay, namespaces, pushback, namespace. Okay, how about we put it into the scope? Pushback, namespace, type, namespace, pushback is to the move. There we go. Namespace index is that. And then we do namespaces, namespace index, name, index name, there. Now this name here, namespace name. I mean, we can make it shorter. We know that this name is this name, so let's do it like that. Name, namespace name. Okay, so mname is here. We can also do this. Name, mname. Find name. Okay. Okay, I think that is fair. Then this pushback thing, create enum by name. Then I think we should put this in scope as well. And then variable, put this here in scope. And then put this here in scope. And yeah. Let's add a comment in here. Access class by index, because there are nested calls to create more classes. Always access class by index, because there are nested calls to create more classes. Note. And then we should also add this node. Yeah, this caused me greater confusion here. Yeah. Always access namespace by index, because there are nested calls to create more namespaces. Yeah. Let's create class. It's just class in this, yeah. Parent is class or namespace. Yeah, here we can do the same, right? Parent is namespace. Namespace name. Okay, I hope we got it right now. Okay. Should also scope this. Yeah. Okay, I think this looks good now. Yeah, that looks more solid. Good. Very happy with that progress. What did we actually? So we set this anonymous thing, right? Okay, where's our breakpoint? Here, and we have some more breakpoints somewhere here. This one, yeah. Okay, let's start a new session. Hopefully we didn't break anything now. Yeah. Let me look one more variable. Find a create class. Yeah. Build class or namespace from function. Class function. Yeah, I think this is fine. Good. Good. So we have this guy, anonymous namespace, and then yeah. I think that means we can delete this one. Yeah. Okay. Good. So, cfence, yeah, it's being created as a class. Music track is here created as a namespace with the hint is maybe class, right? Because we're not sure. Same here. And here we got the anonymous namespace, and that thing will now also it will fail this one, right? Yeah, it will fail that and goes in here, and now I will create that namespace is push back. namespace index. Yeah. And it is anonymous, true. That's the only anonymous one, I guess. The others will be not anonymous, yeah. Okay, and then we have the index here. So we just put a parent index there. And then we have a variable index here that will be put in there, and then is maybe class true. Yeah. Okay. Okay, that seems fine. Let's remove the bookmarks. Or let's look once more through the bookmarks. If there's anything odd. Variable indices. Oh, I see a mistake here. Here, this one is wrong. Function indices. That should be variable indices, right? And here this should be parent. Wait. Parent class index is correct, yeah. Parent namespace index, variable indices, yeah. This is correct. This is function indices. And here, what is this? Function indices. These child class indices. Yeah. Good, good that we checked once more. Let's compile. I think now we can remove those markers. Okay. Then let's run it once more and see what we get there. Good, so the sequence, yeah. The music track, yeah. Yeah, anonymous namespace, yeah. And, oh, this one looks like a class, yeah. Auto-pull class, because it does have a template, right? It can't be a namespace, so this one should go in here, and it does, yeah. That's good. Another one. Yeah. Very, yeah. Okay. That's a lot, yeah. Okay, so it looks like this is all done now. And now it can build the relationships. Yeah. So now the question is, will this is still hit? No, now it doesn't hit anymore. Okay. Okay. Okay, that's good. This doesn't hit anymore. That's good. Okay. Oof. Oof. Yeah, okay. Okay, this is all passing so far, but we are still missing. We are missing now the template arguments. Information in the template arguments. Yeah. How do we do that? Oof. Yeah. Oof. Yeah. Because it's from functions. Because from functions. Classes and namespaces. Okay. Classes and namespaces. I think we should rename this to build classes and namespaces from functions context. Build classes and namespaces from variables context. Or from variable contexts. How about that? Variable function contexts. And then here we say build classes. Let's say build enums and classes, and I think also namespaces. And namespaces. Build enums and classes from function arguments. Build enums and classes and namespaces from function arguments. I think there can be also namespaces in template arguments, right? And arguments in general. Yeah. 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 Enums and classes and namespaces. Yeah. Okay. And then here we do the same. Build enums and classes and namespaces from variable arguments. And arguments means like hold on. From variable argument. Where it's in their context name. Yeah. No, I think it's fine. Have arguments. The context name, I mean, the variable name itself won't have any template, right? But the context name, the class name of it will have eventually a template, and there could be a name inside. Yeah. Yeah. And in the template, this is template. Okay. Yeah, right now it's not entirely clear to me how to implement this, but we get there. So build class or namespace from function context. There we go. From variable context. I want to be specific with the names. That's why they are so long, to avoid confusion, right? Like, okay, what is it actually doing? Better be specific. Better have a long name, be specific. Okay, so build enums and classes and namespaces from function arguments. I think that makes a lot of sense. Good. And then we also need to update that. Build enum. Build enum or class or namespace from function. Function. Should it just be one argument? Arguments. Variable context. function variable. Yeah, I'm not yet sure how these will look here. From variable arguments. Yeah. Okay, let's see that compiles for now. Does, okay. Yeah. Function arguments. Okay, so basically a function, so there are two layers. The functions have arguments and they have template arguments in the across the board. And then there can even be nested types. Ooh. Oh, maybe we don't want to go that far. So you can, yeah. You can have nested types in template arguments, right? So you have a templated type that is part of a template, and that templated type is also template arguments, right? I don't know. Template. It's hard. Function arguments. Yeah. Oof. Maybe before we dive into that, we still have one more thing here in isExpectedClass. Check if in template arguments. Oof. Is function argument, how is this implemented? I think this just looks here into the parameter types which we have pre-prepared. Maybe we need to have here, we need to have another vector here where we say template types. Maybe we say parameter template types. Oof. Man. Parameter template types. Parameter types. This is only used, well, it's used multiple times, but it's function argument, yeah. Yeah. So we can have function argument, and then we can have template types. Yeah. Yeah, so I think what we should do is create template types in both function and in variable, right? Yeah, I think that's the first step. And then we can look these types up the same way we look up these parameter types. But we keep them separate. Maybe here for a function, we could even have a context template types and parameter template types. Maybe. Yeah. Yeah, that's the best idea I have right now. So we have std vector, std string, and we do context template types. It's also add some comments here. Types as string from parameter from function parameter lists. Yeah, and here we say types. Let's say string. Yeah, just types. Let's say data types from function parameter list. Yeah, then we say here data types from context template argument list. Yeah, and then we have a parameter template types, data types from context from function parameter list. I put this up here and everyone is happy. Parameter template types, context template types. Yeah, I think this makes sense. And then in variable, we also put a std vector return type after the string. Yeah, then here std string context template types, data types from the context template argument list. Yeah, so the same as we do with function. Yeah. Yeah. Okay. Yeah. And then we need to basically collect this. We need to collect this somewhere. Template. Wherever we collected this here, there we go. Okay, function get parameter types. Static function get parameter types. Function parameters, yeah. So what we need is a new function here. Get parameter types. This is part of get parameter types. I have the impression that this function shouldn't be in here, no? Create header file set. Yeah, I have the impression that this function should not be part of this class. No. I think we should move it. We take this guy. Yeah, let's move it up here. By the way, we should make this static. Yeah. Make function name with new class name. Yeah, and then so we create a new function here. Get variable name. Make function name. Yeah. So this one is parameter. Make parameter type. Yeah. Get, let's call this make parameter type. Make parameter type list. Yeah. function parameters. Yeah, okay. And it returns the vector. Okay. And so we delete this one here, and then we go here and we call make parameter type list. Let's call it make function parameter type list. Yeah. And then so then we need a new class for the template function parameter type list. And then so we need a new function std vector std string make template make template type list. Make template type list. And I think what we do is we have a function that takes an std string type name, right? So make template type template class name, right? And then that's a const template class name, right? And then we should probably have and then we should have a make template type list. And then we have another one where we do std vector, std string, make template type list. And there we take TCP span of std string, and that will be the template class names, multiple. So that could be, we just give over this string, right? And that will simply do the string, the vector here, vector, let's say types. Oh, hold on. We are here in the wrong function. So types down here. And then for const std string template class name in this, then we do types dot types. I think we can just do plus equal, right? Make template type list, this one, and then template class names. No, that doesn't work. Dot append maybe. Dot no. Dot how do we combine vectors? Hold on. I forgot. There should be some function, no? inserts. I think there's some C++ combine vectors. Inserts. Yeah, that's a very complicated way of doing it. Append range. Append range. Okay, then we do the insert at the end of this. Yeah. So types insert. Yeah. Yeah, I think that would be. But hold on, this will be. Yeah. We won't preserve any hierarchies if we do like a flat vector on this. Do we care about hierarchies? Maybe not. I'm not sure. I mean, we need hierarchies later when we generate the code, right? Because then it will be tricky. Yeah. Yeah, to me, it feels like we need some. We need some breakdown of templates, especially template classes. Template function arguments, we don't care. We just print away and we're happy. But the template classes, we need to make. Where do we, hold on, where we print it? How will we print it? So we have a. Yeah. I think this needs some thought, because when we print out. Yeah. Yeah. Oh, yeah. So, I mean, having a list of just strings of the arguments, that is enough for what we want to do. But I wonder if later on we need some more information. Hmm. So, for example, if there is a, I don't know if we can find an example now. Let me search for 256 this. There we go. So for example, this auto pool class, this one, we cannot just create a class like this, right? So the class will be created with template and then this symbol, and then this should be class something, some name here. And then this one should be an integer type, like int or unsigned int or size t or something like that. Right? So maybe, yeah. Template class, maybe in the class itself. Yeah, I don't know. But I mean, the class needs to know this, a template class. This is not the job of the variable and the function to know details about the class. No. I think this is something we need to do later, in another step. Here we need to have something like to do build class template information. This needs to be some step here. Yeah. Okay. Template type lists. Yeah, so I think the first approach here would be to say, okay, we return this. subtypes, or let's say let's call this all types. Yeah. Then here we do return all types. Let's say here can contain duplicate type names. We don't care so much. And then here we say types, and then all types dot insert all types dot end, and then all types dot begin types dot end, and that's it. Yeah, and then we need to implement this to do implement. Yeah. Oh boy. Yeah, I think it will be good enough if we just have a dump list of template types, nested and non-nested ones. Yeah. Yeah. Template type list. Yeah. Can contain. And so this one. I think this one needs to call itself recursively as well. Yeah. Yeah. Okay, let's visit this next session. Let's see where the current state compiles. Actually, before we end the session, let's actually hook this up so it calls this one here. So currently it calls this one here, right? Yeah. And so I would say we do function dot parameter template types equals make template type list from function dot from parameter types. Yeah, from parameter types, and function dot context template types. We make this from make template type lists from function dot from Decke context name, right? Yeah, this should work. Let's put a breakpoint here. And then in variable, parse where do we put it? This one is on a new one. Add new variable. So function index variable base description. Where do we put it? After we set the strings. base name, decal context. So we do it here, variable dot context template names equals make template type list, and that should be this one here. But we only need to do it if we have this name here. Yeah. So we do it like this. There we go. That should work. You can also put a breakpoint here. Yeah. Parameter types. Decal context name. Decal context name. Parameter types. Function parameters. Why don't we move these guys also in here? Yeah, because if we don't have parameters to begin with, then we don't care. So we can move this here, and the decal context name we can move here. Yeah. 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 Okay. Parameters and parameter types. Yeah, they depend on each other. Yeah. Okay, this should work from the caller side at least, but yeah, we don't have a function body yet. But yeah, this should work. Then we have a breakpoint here. We can just put breakpoints. We could just put breakpoints in here then. That's fine. Okay, then. Yeah. Oh, must return a value. Oh, right. All types. Return all types. Maybe we should all types. I don't like this name, all types. How about we call it how about we call it combined types? Does that make sense? Combined types. Yeah. Let's say builds. Let's put this comment here. Builds template type list in a flat vector. Of the entire template arguments list and hierarchy can contain duplicate type names. Builds template type list in a flat vector of the entire template argument list and hierarchy can contain duplicate type names. Yeah, I think that's good. Okay, I think that is a good start. Then we implement this, which will be a lot of parsing, like this abomination here, and hopefully we can get it to work nicely. Yeah, this one was already quite a bit of a Yeah. Mess. It's hard to read this code here. Need to be very careful looking at it. Yeah. Template type. Yeah, we will figure it out. Good. Then I will take a break here. It has been 2 hours, 6 minutes. I think that was a good session length. Then I wish you a great day or night until next time. Goodbye.